Hello class, sorry I couldn't be in the classroom today with you. My child is sick at home, so I'm home with him. Today we're going to be discussing section 2.6 Algebraic Proofs. Now we started this yesterday, so hopefully this makes sense to you. Today we're going to try to go over the next 6 properties. Hopefully this format works well for you. It's going to be me recording on my iPad, and you get to see the basic notes I was going to cover, but me writing it with the Apple Pencil instead. Hopefully you enjoy. Let's start right in on section 2.6. Our outline of our goals today, I want to cover the properties of equality one more time, the properties 1 through 7. Also discuss the field properties, and those are new properties. That's properties 1 through 6. Now, I will give you a little bit of work time at the end of class today. The homework that I assigned to you on Friday is actually due today or Thursday. I gave you the choice of it yesterday. It's 1 through 13 odds, 16 through 28 evens, 34 through 41 all. Just make sure that you're kind of ignoring the directions. I would like you to tell me which postulate number the problem is just trying to discuss with you. And then on the certain problems that always ask for always, sometimes, and never, you just have to choose one. You don't have to explain yourself. Now, some of you have turned this in yesterday. That's great. You're already done, so you have some free time to work on whatever assignments you have. I know it is the start of the new quarter, but there's probably some assignments out there that you need to get done. Let's jump to the next slide here. The properties of equality that we discussed yesterday. Now, we did discuss, if I can grab my pen here, we did discuss the reflexive property. That was one where we discussed, A is equal to A, or some algebraic expression is equal to another algebraic expression. Now, I know these properties are properties of equality, but you can associate them with expressions. We talked about the symmetric property. The symmetric property is pretty straightforward. It's when you take an algebraic expression and you flip it. You change the right and left side completely. To give you an example of this, let me write with my pencil here. An example of symmetric property would be something like y equals 3x plus 2. And you're able to switch the right and left side around where you can make it 3x plus 2 equals y. That's a perfect example of symmetric property. It's still the exact same problem. It's just that we're switching the right and left side. Let's move on. The next property that I want to discuss is transitive. Now, transitive property is where we can take 2 equations and make a new third one. It really mimics substitution, but the problem is we're not actually solving, we're just setting it up. I think the example we used yesterday is the law of syllogism. That property is where you have a daisy chain of events occurring and they're all somehow connected. Now, the transitive property is basically used at the end of a proof when you're trying to connect the beginning line to the last line. So as you can see from the example I provided you, A is equal to B, and B is equal to C, then A is equal to C. So it's connecting the beginning to the last term. Now the last 3, if I can highlight these last 3 are unique. These last 3 are unique. Last 4. They basically help you set up an algebra problem, but they don't actually solve it for you. That's unique. The example that I used in class yesterday was that you can magically add 2 to both sides of an algebraic expression or equation. It doesn't actually solve. We're not going further than that. It's just the simple fact that you added a number. So let me give you an example here. Let's say we had 3x plus 1 equals 10. And 10 is not showing up too well. Now, the idea is that what you're allowed to do on this problem is you're allowed to subtract 1 from both sides. That's the subtraction property of equality. It's not the fact that I know I'm going to get 3x equals 9. It's just the simple fact that you're allowed to subtract numbers to both sides of the equation. You have to keep it a balanced equation, so you have to do it to both sides. Hopefully that makes sense. Let's move on. Slide 4. These are now the field properties. These should be brand new to you. The field properties are the properties we actually use to solve an equation. or to simplify an expression. They actually take us down. Now the first one, I have a different name for this one. Let me mark this on here. This one, it's entitled the closure property. It's actually known as substitution. I would actually write that word in your notes, that we're actually going to call it substitution from now on. You can call it closure, but substitution will make more sense. It's when you're actually doing some form of arithmetic in the middle of an algebraic expression or equation, and you're replacing the number. And you can see the examples I provided you. Like the example I would be doing is on that problem where I had the 3x plus 1 equals 10, and I subtracted 1 to both sides using the subtraction property of equality. Well, the next line, I would actually have to make this answer a 9. That's substitution. It's coming up with a new number that wasn't previously on the page, but it's simple arithmetic. That's substituting. You're replacing numbers. So as I said, when we're going through these problems, there's a lot of properties. This one should hopefully make sense. Most of the math you do is substitution. It's not all of the math, but most of it. Now let's move on to the next slide. Okay, this one is called the commutative property. This property can be confused with symmetric. I want to keep that clear. It is different than symmetric property. Symmetric property only applies to equations. Commutative property can apply to expressions and equations. So let me give you an example of something like a little more rigorous here, a little more large, so you can see the overall frame of it, and then I'll compare it to the one we did yesterday. So I'm going to make an example here. So let's go 3x plus 2 plus 5x plus 4. Now what we're allowed to do is we're allowed to switch the variable, like the 5x and the 2. That's commutative. Commuting, the root word commute is to move, to group and move. Like if commuters commute to work, right? They are grouping together and traveling to work. They're moving. Well, that's what we're going to do. We are literally going to group these two objects together and switch their locations. The new way that we'll look at this problem is it will be written 3x plus 2, and that plus 2, correction, the plus 2 will now be a 5x. Oh man. Okay, I'm having issues with that. That's a 5x, and the 2 is now sitting here, and the 4. Now the reason why I did that is because I want these two items to be grouped together, and I want these items to be grouped together. So hopefully that makes sense to you. And again, we can go further with substitution later, but right now commutating is just to move. That is different than symmetric. Symmetric property is when you take an equation and you're going to switch the right and left side. That is symmetric property. This part right here is where you're going to switch the right and left side, and you switch it like this. It's going across the equal sign. I have no equality symbol on this previous problem. This problem right here, I have no equality symbol. So I'm merely just moving terms around. We do this a lot in the middle of a problem when you want to group like terms. That's what we call them. Like terms are items that have the same variable or maybe lack of a variable. Let's move on to the next slide. The associative property. The associative is better known as the grouping method, the grouping symbols property. It is when you introduce a bracket, parenthesis, some type of grouping symbol into a problem, and you're merely going to move the parenthesis. You're not going to move any of the terms. Let me explain it. It really only applies to two types of math, addition and multiplication. So let me give you an example here. I'll actually mark up my document. Hopefully this will work a little bit better than the last time. So let's say I made a problem like 4 plus, ooh, that is crazy. Let's go 4 plus 3 plus 2, and I have a parenthesis here. The parenthesis itself, I'm allowed to switch it. So I can get rid of these parentheses and actually move them to a different location. That's the associative property. Now, why it works for addition and multiplication is because it doesn't actually change your answer. This answer will still be 9 in the long run, right? This is still 7 plus 2, which is still 9, doing a lot of substitution property. And if I went back to the original that I had up here earlier, and I had the parentheses in the back, it's still 9. It's still 5 plus 4. Now you're probably thinking to yourself, okay, Ward, then why would we ever do it if the answers are the same? Why would you choose? You're allowed to switch parentheses when you can't actually add the terms in them. So let me get rid of these examples here and give you an example where you would actually probably require to switch the parentheses around. In fact, I'm going to use that example that I did earlier. The idea that I did 3x plus 2 plus 4. And let's say the parentheses was in the front. Well, technically, I can't add these terms. They're not like terms. One has an x, one doesn't. So what I'm going to need to do is get rid of the parenthesis and actually add the terms in the back together. Let's see. And add the terms in the back, which the actual 4 plus 2 would make 6. Because I would actually be adding the like terms in the back, so the parentheses are actually back here now. That's associative. It's the simple fact that I move the parentheses from the front to the other side. It's not going further. That would be substitution. Hopefully that made sense to you. Let's move on. We'll discuss this when I get back on Thursday. Now the identities property. The identity property is, there's two of them. There's the additive identity and the multiplicative identity. These are easily confused with substitution. Identity is doing some form of arithmetic. So some form of adding, subtracting, multiplying, dividing. But it's not going to change your answer. So there's two unique ways you can do arithmetic that wouldn't change an answer. And as you can see them, the idea is that we could add a 0. That's called the additive property, or the additive identity property, right? It's adding a term, so we're doing some form of arithmetic, but your answer never changes. Now you're probably thinking to yourself, why would I ever add 0 to something? Well, it's in the middle of a problem when you're solving it, right? If I give you an example here where you might have to use it, 3x plus 1 equals 10. At one point in that problem, I know we're going to be subtracting 1 to both sides. Oh, correction. I think I said 10. I wrote 9. I was getting ahead of myself. So I was subtracting 1 to both sides of the equation. Well, at one point, this problem actually makes a 0 over here. Now, a lot of people always just forget to write it. But that simple step later is I will actually have to add 0 to the 3x. That's going to be a form of identity later. Now, the properties that I'm doing here where I'm actually adding the 1 and negative 1 or adding the 10 and 1, that's not identity. That's substitution. And in fact, this problem right here is actually a different property altogether. We'll talk about that one next. But the simple fact is right here, I will have to add 0. So that's your additive identity. Now, where you multiply by 1 is, let me get rid of these examples here. Doing the multiplicative identity is anytime you have a variable like an x, you're allowed to put a 1 in front of it. Because maybe you need to add, let's get rid of the 1 again, maybe you need to add the x plus a 3x. Well, the idea is you're going to have to introduce a 1 in front of the x so you actually can add the variables together, because they do have what they call a leading coefficient. So you have to put the numbers out front. Then you can add them later because there's actually a step in between, but eventually you'll get to 4x. So introducing the 1 is actually a multiplicative identity. You are multiplying an x by 1. It doesn't actually change x. It just adds a number in there, a 1. That's usually where we use it. I'll come up with more examples later. That'll be Thursday, but that's the idea, introducing the number 1. Let's move on to the next slide. Okay, we're coming down to the last 3 slides here. The field properties also have inverses. I used that term yesterday. An inverse property is doing an opposite, right? Well, there's 2 types of opposites. There's the property of opposite, which you can actually see marked here. Let me highlight here. In fact, this is the property of opposites. Property of opposites is any time in the middle of a problem, and I was actually just doing one a little bit ago, when you add or subtract numbers and they cancel each other out to make 0. So let me give you an example I wrote up here earlier. It had been that problem where I had 3x plus 1 equals 10. and I chose to subtract 1 to both sides. Well, at one point, this part right here actually makes 0. That is the property of opposite. You're adding things to make 0 or subtracting them. They are truly opposites of each other. That's property of opposites. It looks like arithmetic, right? But making 0, using 0, multiplying by 1, those are very unique types of properties. So it's not substitution. It has its own property name. And you're probably thinking, this is a lot. Like, there's a lot of properties here. I'm getting confused. We're going to practice these. We're going to do one at a time when I get back on Thursday to make sure that you can see when you need to use it. Some people get it right off the bat. Like, you understand, like, oh, I'm going to add 1 and negative 1. That makes 0. That's a unique property. It's not always substitution, like I said earlier. But again, we will practice this more. Let's continue on. The other type of inverse property is called the property of reciprocal. It is a type of opposite. A reciprocal is, and you've probably seen that term in Algebra 1, it's when you make a fraction. Well, it's used in a problem like the problem I wrote up earlier, which, ooh, wow, that is really big. It was used in the problem like 3x equals 9. Well, at one point, I'm going to have to choose a reciprocal to the number 3 to get rid of it. So a lot of times I always just tell people to divide by 3. And that's division property of equality. But you're allowed to do this even when there's a fraction in front of the x. Not just a whole number like 3, but when there is a 1/3 out front. Now you're going to actually need a reciprocal to get rid of that number. And so that's a little bit different type of math. That's going to require that you actually flip that fraction over, which is 3 over 1. And 3 over 1. Ooh. Wow, I'm having issues with that. Times 3 over 1. There you go. And so at one point, that will help me cancel out these terms here. And we'll explain that more. But that's a reciprocal. Now, there is a form of reciprocal on that earlier problem that I showed you. Let me go back to that one. Three, 3x equals 9. What reciprocals actually do when you actually multiply them together, or you divide in this case, where I'm going to divide both sides by 3, that's the division property of equality. When these numbers actually divide and make the number 1, okay, actually making the number 1 is a unique number. Well, making the number 1, that is your reciprocal property. That's what would have happened earlier when I used that 1/3 and the 3 over 1. It would have made the number 1. The terms cancel out. That's a reciprocal. It makes 0 or it makes 1. That's what you're thinking. On this other side, this is just substitution. It's random arithmetic that results in a random number. 9 divided by 3, well, it just turns out to be 3. It's not special. It's not 1 or 0. So that's what you have to be thinking about. Okay, so we did have both properties. We had substitution and a reciprocal there. Okay, last slide here today. This is our absolute last one. The field properties. Talking about the distribution property. This property is the one that most people are comfortable with. Most people know this property right off the bat. Distribution is any time you multiply a number through a parenthesis. Like, for instance, 3x plus 2. I should change my marker here. When you actually multiply, you have to, what we call, distribute the item through. Distributing the mail is when you hand mail out, right? Well, I'm going to distribute. I'm going to hand out the 3 to both terms inside the parentheses. So you're actually going to take the 3 times the x and the 3 times the 2. Now notice, I didn't actually write my math. I didn't actually multiply 3 on x, and I didn't actually multiply 3 times 2. I just put them next to each other. I handed the 3 out. That's distribution. Going further in this problem, actually multiplying the 3 times 2 and the 3 times x, that requires the other properties we talked about earlier. That will require changing grouping symbols, right? Moving the parentheses around. That would be associative. Then actually taking 3 times 2, which would be substitution. I do need a number in front of the x. That would require a different property name, which is the multiplicative identity, where I multiply by 1. There's a lot of properties. As you can see, properties are starting to add up. There's a lot here. We will continue this on Thursday when I get back. So hopefully we'll practice this more and more. Now, I want to show you the purpose why distribution was made, other than this one algebra problem. Distribution is actually made for the purpose of doing really complicated multiplication, like let's say 3 times 99. Okay, it's a tough problem. Taking 3 times 99 requires that you can do either column method or lattice method, but there's a way to do it in your head without thinking about it. Like, for instance, taking the 99 and making it 100 minus 1. And now I can distribute the 3 over that, and that makes that math a little bit easier to look at. Because now this turns out to be 300, if I actually take the 3 times 100, and the 3 times 1 turns out to be 3, and I can do this math in my head faster than 3 times 99, which this math turns out to be 297. That's the purpose of why distribution was made. It was actually made for doing simple multiplication. Hopefully this made sense to you. If you have any questions, don't worry. I will be back. We will fill this in. I know this is the first day of going through these properties, so you might be a little bit overwhelmed. But I promise you, don't be. Trust the math we're going to be doing for the next couple days in here. Obviously, your homework today, page 130. Make sure that you are paying attention, that you're doing odds, evens, and all. Make sure that you are taking the time to tell me which postulate number it is, not just writing postulate, but postulate like 2.1 or 2.7. If it's a theorem, fine. Some of these problems in the middle, make sure that you're on, if they ask for always, sometimes, or never, think about all the outcomes that could have happened. If there's a rare case, that might be sometimes. If it never happens, that's an obvious one. But think about them before you just jump to the answer. You can ignore the directions and say, explain your reasoning. I don't care for that. I just want to know if you know your postulates and your reasonings. Okay? Have a nice day. I will be here for parent-teacher conferences tonight if you'd like to stop in. Parent-teacher conferences are 4:30 to 8 tonight and on Thursday as well. Look forward to seeing your parents if they're going to come tonight or Thursday. And if not, have a great week. Remember, girls basketball has open gym starting Wednesday. That's tomorrow. I know we don't have classes tomorrow, but we still have open gym after school. So enjoy your day. Good luck on your homework.